Assalamu alaikum everyone, my name is Mohammad Davar Zahid and I am currently a second year medical student, and welcome to our video in which we're going to be talking about mechanisms of organic chemistry. This is going to be the first video in the series in this new series, and we're going to be talking about fission and about free radical substitution. And I know that these aren't considered to technically be mechanisms, because I know that you associate the word mechanisms to stuff like electrophilic addition, nucleophilic substitution, and all of those things. However, I think that this is something that's quite important for you to understand. If you don't understand fission, if you don't know free radical substitution, it is something that will, अगर इसका नहीं पता होगा तो a lot of things won't make sense, especially talking about fission. So think about this as an introductory video. If you don't want to go over this introductory video, if you already know what fission and free radical substitution is, then I would suggest you can skip to the next video in which I will be talking about electrophilic mechanisms. All right, so let's get started with this video. Okay guys, talking about fission. So fission is really simple. All right, what is fission? Fission is essentially that you're breaking a bond and you're dividing electrons. All right, it is further divided into two types of fission. There's going to be homolytic fission and there's going to be heterolytic fission. All right, and they're both quite distinct. All right, let's talk about homolytic fission first. So in homolytic fission, we say that there is going to be an equal sharing. That's the important thing. It's going to be equal. All right, let's look at an example. Let's talk about X and Y. So between X and Y, what's present? There's an electron cloud. Let's make it a bit easier for ourselves. That's one electron, that's the second electron. All right, so there's an electron cloud sitting in the middle, and what happens is that this bond is equally broken like this. Okay, it's completely broken, and what do we have as a result? It's equally broken. That's the key word. We have an X and we have a Y. And what do we have with this? We have this thing. And what does this mean? It means that ye bhi negative hai, this is negative, and this is also negative. All right, and this obviously is not good. So you guys see this electron over here, this electron over here. It's an equal sharing of electrons. All right, and we basically say that, so in homolytic fission, if I was to sort of, for your exams purposes, so this is essentially what's happening, but writing a few things from your exam purposes, that what is homolytic fission, talking about that. So we say the definition, because obviously exam can they want you to know the definitions and stuff. So for the exam, we say that in homolytic fission, there is an equal sharing of electrons, which produces two highly reactive atoms or ions or whatever atoms called, that's the word that I want you guys to be aware of, called free radicals. All right, or these free radicals, what do they have? They have unpaired electrons. So essentially guys, they're very unstable. They're super unstable. They're super unstable, and what ends up happening is that they go on to create more free radicals, and we'll look at that when we talk about free radical substitution. But right now I just want to cover fission. So we've talked about one thing, we've talked about homolytic fission. All right, we've done a really nice overview of it. We've gone into the required details, what would be tested in your exams. It's a really basic thing. All right, it's probably the easiest concept that we have in organic chemistry. All right, so moving on to heterolytic fission. Heterolytic fission is really simple. Like, this is something that we've been seeing for a very long time. It is the good old unequal sharing. And again, we'll look at a diagram and we'll try and understand it us tarah se, okay? The same thing, we have an electron, we have a compound, and what do we have here in the middle? We have two electrons, or we could say, oh, there's a electron cloud present over here. All right, what happens is that one is going to be taking all of these electrons. All right, and when it takes all of these electrons, we say that it is a negative ion. It is a negative ion, or we can just call it an anion. All right, so if you were to quickly look at this, X takes both the electrons. Normally we don't show both the electrons, but I'm showing them just so that you guys know. And what is the charge over here? The charge is going to be negative. And additionally, we are going to be having Y. And what would be the charge on Y? Y would be positive. Why? Because it has been robbed of both of its electrons. It does not have any electrons compared to this. Not any electrons, but it does not have these two electrons. All right, the electrons that were present here. It probably has its own electrons, but yeah. All right, so if I was to quickly draw it over here, it sort of looks like this. Okay, no, actually it sort of looks like this. That all of this went to this, iske paas aa gaya, and this poor guy was just empty. All right, it didn't have anything. So that's what I want you guys to look at. So heterolytic fission mein, what happens is that we have unequal sharing, that this bond breaks, and it breaks in a manner that one gets all the electrons, the second one gets nothing. So coming over here and talking about it from an exam point of view, because I need you guys to be prepared for that as well. What do we have over here? There's an unequal sharing, and we basically say that production of two oppositely charged ions, and we can say okay, we're generating a anion and a cation, okay? But okay, that's not that relevant over here. And production of two oppositely charged ions as one atom gets all the electrons from the bond, and then from the bond, and the second one obviously does not get anything. Over here you can see this poor guy, he did not get anything. Alright guys, so this is basically homolytic and heterolytic fission. Really simple, really easy. The reason why I wanted to discuss this before I got into the proper serious mechanisms is because you'll see these words a lot, that oh, homolytic fission kar di, heterolytic fission kar di, and if you don't know your way around these terms, it's going to be really difficult for you to understand the mechanisms. Alright, now we basically want to talk about free radical substitution. Again, it's not technically a mechanism. It's not like electrophilic addition, nucleophilic addition, or substitution, and all of those reactions. It's not like that. It's sort of an informal mechanism, I would say, but still it's quite important. It's highly tested, and that's why I want to include this. All right. Alright guys, talking about free radical substitution, if you guys have understood the homolytic fission ka mechanism, so this is going to be really simple. Free radical substitution. Okay, what is happening in free radical substitution? So essentially, we can do this in a lot of different cases, but the thing that we want to know is in the case of a typical hydrocarbon. So we take a hydrocarbon and we generally take halogen atoms, all right? And what happens is that the halogen will replace hydrogen atoms in the hydrocarbon skeleton, in the carbon skeleton. What is a carbon skeleton? It basically means a carbon chain. Alright, so halogen will start to replace the hydrogen atoms. Alright, and the thing is, what I want you guys to know, that there's no preference. It's not that the halogen wants a specific position or anything like that. There's really no preference. Alright, no preference, and I'll elaborate this in the notes as well, thoda sa, ताकि you guys aren't confused. This basically means that halogen can replace or substitute any hydrogen. Right? Any hydrogen can be replaced or substituted. Really simple, not difficult at all. We can replace any hydrogen, and we can also replace all of them. Alright, we can create something like it's a basic carbon skeleton, and all that it has are halogens. Let's just, all of it has Cl. Obviously this is difficult to create, but we can obviously create this. Alright, this is what I want you guys to understand. Okay, in this reaction, it's not like other reactions that, oh, acha, we just did one thing and that's it. This reaction, if we don't stop it, it can just continue to go on and go on. Alright, and why does that happen? Let's look at that. So free radical substitution as a whole is going to be having three components to it. Alright, the first component is going to be something called initiation, which is also called generation. Okay, some books call it as generation, and this is something that I want you guys to be aware of. Alright, it's the same thing that we just talked about It is homolytic fission. Okay, so in homolytic fission, we just talked about the initiation or the generation of free radicals. And over here is where my free radical is produced. Free radical produced. All right, guys, what I want you to know over here specifically is that for free radical substitution, especially this halogen one that we're doing, which is a part of our syllabus, what happens is, let's take this chloride, really simple, right? बीच में क्या होता है? बीच में there is going to be an electron cloud and 2 electrons, and this is going to be broken into Cl plus Cl, and this is going to be a free radical. All right, this has an electron, this also has an electron. They're incredibly negative. All right, okay, what I want you to know over here is that this process needs energy, and this energy is going to be light. All right, that's it. Okay, so sunlight happens, causes this process of homolytic fission and creates 2 beautiful looking but very, very bad, actually let's just do it like this, free radicals. All right, this is going to be the first step. The first step is now done. Initiation, generation, we've created a free radical. Now this free radical is going to go on and cause a lot of problems in the second stage, which is going to be propagation. And propagation is exactly what it means, that it's going on and it's going to spread its word. It's going to go on and create more free radicals. All right, and to just describe it over here, what is a propagation? Propagation is the attack of free radical on alkane, or I would just say on carbon skeleton. All right, it's sort of a neutral term to use. All right, okay, so what is happening? Thoda sa hai, it's just really small, but I need you guys to understand this. All right, just one small rule, which is that once a free radical is involved, the product will also have a free radical. All right, okay, the word that I want you guys to look at is once a free radical is involved. I'm not talking about multiple free radicals right now. All right, hold your horses and just look at what I'm going to do. Okay, so guys, propagation is something that can just go on and on and on and on, and like it's just something that can just go on for a very long time. All right, okay, so basically what happens over here, is there's this Cl, which is a free radical, and there's going to be a, let's just go with a really basic structure of methane. There's methane. Now what happens is, guys, that this free radical essentially, it pushes the hydrogen out. That's what I want you guys to understand. All right, it pushes the hydrogen out and it kind of steals the hydrogen away. All right, and what the product is this thing. All right, it's this thing. Let's say इसने ऊपर वाला, it has stolen this ऊपर वाला hydrogen. All right, and I'm going to be having HCl. Guys, what's my rule? The product will also have a free radical. And what is happening? The chloride is going, it's going to be stealing a hydrogen from the, from the methane molecule, or from the carbon skeleton, or from the alkane. All right, so this thing is now going to become a free radical, and we're going to show it by creating this dot over here. So you see, there's a free radical here, there's a free radical here. It's propagating itself. Now your question is, oh, okay, but this kind of doesn't make sense, because you told me that halogen can replace any hydrogen. Now let's go to that. This was actually the first step. All right, the first step of propagation. Let's use a different color and let's go to the second step now. So in the second step, what happens is that this thing, this free radical that we've created, let's just quickly write it down. So this free radical goes and it attacks another compound. It could be anything, but let's just go with a Cl, with a Cl. All right, it goes and it attacks the Cl, and what it does is that it actually steals a Cl and attaches it over here. It steals a Cl and attaches it next to itself. So let's just quickly draw it out. I have my Cl over here, and what is going to be my end product? My end product is going to be my second product is going to be a free radical. All right, so free radical here, free radical here. And guys, this process can just keep on repeating itself. I'll just draw out two more because if you can skip this if you want to, but this is just something that I want to make sure that I've really hammered into you guys. All right, so moving on to the third one. So what we do is that we take our, let's say we have another free radical here. It's a Cl, maybe it's this one, maybe it's someone else. We don't really care about it. All right, and it comes and it decides to attack this really beautiful halogenoalkane that we've created. All right, and it decides that, oh, I'm going to attack this, and it attacks this, and what does it create? It creates a HCl. Why? Because it steals this hydrogen away. And along with the HCl, what does it create? It creates a free radical. All right, and now guys, this free radical is going to go, I know it's a bit long, but isko sahi se kar lena chahiye. We shouldn't leave any doubts. So now this free radical, it's like, oh, I also want to stop being a free radical, and it goes and it finds another Cl molecule, and it causes them to break essentially. And by doing that, it is going to be creating this molecule. And guys, now this entire step I've written down 4 times for you guys. This can just go on and on and on and on and on for how long? One small thing, there has to be a Cl free radical over here. Do you guys see this? Free radical here, 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 free radical here. And this is why guys, free radicals are really horrible. All right, because it's a chain reaction that is going to just continue on and on and on and on. And yeah, but just keep this thing in your mind, because they love to give you equations of like propagation of the propagation step. They love to give you equations. They're like, okay, is this equation correct? And if you guys remember this rule, it's all going to be really easy for you. All right guys, now let's move on to our last step. But before that, I just want to make sure that you guys remember that this reaction will continue to proceed, but the propagation has no end essentially. All right, till we enter termination. Okay, so by itself I could cause propagation to exist as long as I want it to exist. All right, till I basically run out of stuff. But again, the molecules, they'll continue on reacting and reacting and reacting, and that brings me to the last thing, and that is going to be termination. All right, and termination is just exactly what the name says. It's going to be terminating the reaction. And guys, for termination, I need you to remember something, that it's going to be very exothermic. And that is sort of a key word, that if they're talking about free radical substitution, if they mention that, oh, there's a step that is very exothermic, so your mind should automatically go towards termination. All right, okay, so what essentially happens in termination? In termination, two free radicals meet. The way I like to think about this is that two bullies, so a free radical is a bully, all right, it goes and it bullies people. So two bullies meet, two free radicals meet, and they have a very heated fight, a very exothermic fight. And in the fight, and after the fight, they cease to exist. All right, both of them, they've beaten each other up a lot, and now they're like, oh, we can't do this for anymore, and let's just put an end to our fight. So guys, let's just again, let's look at a couple of equations to make sure that you guys are well versed in this. Let's first draw out our chlorine free radicals. So two chlorine free radicals can meet each other and can just create a chlorine compound. And guys, always write heat, because a lot of heat is going to be created. A lot of heat is going to be created, okay? Because these compounds, they're very reactive, and when they become stable, they have to release all of that energy that was causing them to be unstable. All right, okay. CH3 free radical, so this is essentially this thing, sorry, just a second, it's essentially this thing that we created, CH3 free radical. So guys, what happens over here is that this is, let's say, going to meet a Cl free radical, and it's going to create a CH3Cl plus obviously heat. Okay, and let's just look at one last one, and this one is interesting. CH3 plus CH3, both are free radicals, and they can actually create CH3. Look at this, CCHHHHHH. So guys, this is essentially what's happening. Okay, it's ending the free radicals. But one thing that I want you to know from your exam perspective, I know conceptually you probably understand everything now, but one thing that's quite important for your exam perspective is that, guys, my question is, can the termination step, can termination or as a whole free radical substitution, can termination or free radical substitution increase substitution? Can this increase the length of the carbon chain? Okay, is it possible for it to increase the length of carbon chain? That is my question from you all. It's literally on the screen. The answer is yes, it can. This does not mean that it will definitely do this. That's not what it means. But all that it means is, okay, it can do that. It can do that. All right. It's not something bound, but it is something that we can possibly do. Does that make sense? I hope this makes sense. Sorry, I'm just too used to like live classes, so I just want to make sure that you guys are still understanding these things. Okay, guys, there's just a few things that I want to talk about. Overall free radical substitution, the stuff that I've discussed as a whole, but again, I just want to make sure that it's really hammered into you guys. All right, so I'll just write it over here that overall free radical substitution. It's just some overall stuff that I've mentioned, and I really want you guys to be aware of all of these things. So first of all, there are 3 steps. Okay, कौन से steps होते हैं? Initiation, propagation, termination. 3 steps, and all 3 steps are actually exothermic. Okay, some are not that exothermic. Okay, the most exothermic step is termination. Okay, initiation is still quite exothermic, but again not as exothermic as termination. Termination is super exothermic. What I want you guys to remember is that it's super exothermic. Okay, what does this entire reaction do? We say that it halogenates the hydrocarbon. Whatever hydrocarbon it is, it's going to cause halogenation of the hydrocarbon. Okay, and the last thing that we have is that we can also have other reactions. Okay, so we can have a wide variety of reactions, and this is something that I have wide variety of reactions. Let me just quickly write this down, then I'll explain this. So guys, essentially what I mean is that we can have a wide variety of reactions happening simultaneously at the same time. Okay, it's not that we're only going to be having a reaction between Cl and CH4, but at the same time we can also have a reaction between the 2 hydrocarbon chains, and that is something that I want you guys to understand, that free radical substitution, if you've created a free radical, it can go and it can mess up with other molecules, or it can go mess up with itself and stop existing, or it can create more of them. We don't really care, because a lot of kids just seem to think about this in terms of the halogen and the hydrocarbon, but what I want you guys to really remember is this thing can also exist, and through that we can increase the length of the carbon chain. And guys, that is it for the first video in our series for mechanisms for organic chemistry. The next video inshallah is going to be related to electrophilic mechanisms. See you all in the next video.